we have got the fitness information for the whole population of solution selected at random initially. Now, as I told that as there is no guarantee that all the solutions will be equally good. So, what I do is we try to use one operator called reproduction scheme just to find out or just to select the good solution which will form the mating pool. Now, step 3 I am just going to discuss the reproduction schemes. Now, if you see the literature, we have got a few reproduction schemes. Now, out of all the schemes, the oldest one is the proportionate selection or the Rouleau-Wheel selection. Now, let us see the principle of this proportionate selection or the Rouleau-Wheel selection. Now, here the probability of being selected in a mating pool is proportional to the fitness. So, the higher the fitness value of a particular solution, the more will be the probability of being selected in the mating pool. Now, this particular the Rouleau-Wheel selection or the proportionate selection is implemented with the help of one Rouleau-Wheel. Now, I am going to discuss the principle of this particular the Rouleau-Wheel. Now, here we have got a fixed pointer and we have got this particular Rouleau-Wheel. On the top surface of the Rouleau-Wheel, there will be a few marking and the marking of this particular f1, f2 up to fn, these are all the fitness function values. Now, the area covered by a particular the GA string, that is equivalent to its fitness value. So, the higher the fitness value, the more the area will be occupied by that particular the string on this the top surface of the Rouleau-Wheel. Now, the way it works, the pointer is kept fixed, the Rouleau-Wheel is rotated either clockwise or anticlockwise. Now, once it is rotated, after some time it is going to stop, and if it is going to stop here, the way I have shown it on this particular figure. So, f1 is going to be selected for the mating pool. Now, similarly, the fn can also come in front of this pointer, the fixed pointer. In that case, the nth string will be selected for the mating pool and so on. Now, here the probability of selection is nothing but the individual fitness divided by the sum of all the fitness values for the whole population. So, the probability that the ith solution will be selected in the mating pool is nothing but f I divided by the summation f I varies from 1 to capital N. So, N is nothing but the population size. Now, let us concentrate on the GA population. So, this is the initial population which I have got, and that is created at random. For each of the GA string, I have got the fitness values. Now, I can find out what is the probability of being selected in the mating pool for each of these particular the GA string. And once I have got the probability values for the whole population, the sum of probability values will be equal to 1. Now, here I am just going to put one note. The GA search depends on the factor like population diversity, that is nothing but exploration, and selection pressure, that is nothing but exploitation. Now, to discuss this further, let me try to take one example. Now, let me consider, say Dr. X has joined say one institute as a faculty, and he wants to go to the top, he wants to reach that particular top position, and how he will have to make all such planning of the activities. Now, if he wants to concentrate on many areas, then population diversity will be more, and if the population diversity is more, he may not be able to concentrate on a particular area in depth, and consequently he will not be able to carry out search, carry out research in that particular direction. He will not be able to produce good research results in that particular in a particular direction, and consequently he may not get promotion in his career, and there could be stagnation. So, if the population diversity is more, that is exploration is more, there is chance of stagnation. Now, on the other hand, if the selection pressure is too much, there is a possibility he will be concentrating more on a particular area or two areas, he will be able to go to the depth, he will be able to produce good quality papers in large in number, and there is a possibility that he will be getting the promotion bit early. That means, to reach that particular level might be he is going to exploit others. So, if the selection pressure is more, the chance of exploitation is more, but there is a chance of premature convergence. Okay. So, this particular fact has been copied in the artificial way in genetic algorithm also. Now, if we want to ensure a very efficient GA search, there should be a proper balance between population diversity and selection pressure, so that there should not be any premature convergence. At the same time, stagnation is also not welcome. Now, how to set the premature convergence, or how to remove that problem of premature convergence. Now, here actually what we do is, if you see this particular the roulette wheel selection, so there is a chance that there will be some sort of the chance of premature convergence. So, that particular problem is there. Now, let me take a very simple example, some numerical example let me take. Supposing that I have got one population, GA population of size say n equals to 4, and if I just consider one roulette wheel here, supposing that for the first solution, that is F1, whose fitness is F1, is say 40% of the total fitness, F2 is say 30% of the total fitness. So, 40 plus 30 70, then F3 is say 20%, that is 90, and F4 is the remaining 10%, that is the 100%. Now, if this is the situation, what will happen is its probability will be 0.4, its probability of being selected is 0.3, its probability of selection is 0.2, its probability of selection is 0.1. Now, this is one scenario. I am just going to consider another scenario where same n equals to 4, but fortunately or unfortunately F1 is say 80%, F2 is nothing but say 10%, F3 is nothing but the 7%, and F4 is nothing but the 3%. Now, here the probability of being selected is 0.8, here it is 0.1, here it is 0.07, here it is 0.03, and the sum of the total probability is equal to 1.0. Here also the sum of the total probability will be equal to 1.0. Now, let us compare these two scenarios. Now, here in this particular case, the probability that the first string will be selected is 0.8. Now, if this is the situation, and if I use the proportionate selection or the Rouleau selection. So, 80% of the total population will be occupied by the first string in the mating pool. Now, 80% of 4 is 3.2. So, out of 4 string might be the 3 positions will be occupied by the first string. So, here the chance of premature convergence will be more, diversification will be less. But if I see this particular scenario, here once again the population size is 4, but here the scenario is slightly different. For the first string the probability is 0.4, second string probability is 0.3, third string is 0.2, fourth it is 0.1. But here the chance of premature convergence will be less, but here the chance of premature convergence will be more. So, if I use proportionate selection for this particular problem, so I am going to face this particular the premature convergence, the chance of premature convergence and less diversification, which is not the situation here. For this type of problem, so the proportionate selection or the Rouleau selection may work in a better sense, but it may not work here because there will be more chance of premature convergence. Just to summarize whatever I discussed, like if I use proportionate selection or the Rouleau selection, there will be a chance of premature convergence. Now, to overcome that, so what we do is we take the help of another proportionate scheme, that is called the ranking scheme. Now, in ranking selection, what we do is once again we take the help of the proportionate selection, but that particular proportionate selection will not be in terms of the fitness information, not in terms of the probability value the way we calculated based on the fitness information. Instead, it will be based on the ranking of the solutions in the population. Now, let us see how does it work. Now, this is the typical scenario which I discussed. Now, here see for this particular F1, there is 80% chance that it will be copied in the mating pool and it will create the premature convergence. Just to overcome that, we take the help of this type of ranking selection. Now, what we do is, now if I just concentrate here, I can find out in terms of fitness, like F1 is having 80%, F2 is 10%, F3 is 7%, F4 is 3%. Now, in the ascending order, if I just sort this particular GA string, the lowest fitness F4 is the lowest fitness. So, the fourth solution will come first, then comes your next is the F3. So, 3 will come, then next is 2. So, 2 will come, after that the first one will come. So, in this is the sorting in terms of your the fitness. Now, if this is the sorting in terms of fitness, what we do is we try to assign some rank. The string which is having the lowest fitness, that is assigned rank 1. The string which is having the next higher is assigned rank 2, next is rank 3, next is rank 4. That means, the string which is having the lowest fitness is assigned rank 1 and the string which is having the highest fitness is assigned rank 4. And now, what we do is we add the rank values like 1 plus 2 plus 3 plus 4. So, this is nothing but 4 plus 3 7 plus 2 9 plus 1 10. So, this is 10. This is the summation of the rank values. Now, here we try to calculate in a ranking selection the probability values in a slightly different way. That is, for F4 which is having rank 1, we will be getting the new probability value, that is 1 divided by 10, that is 0.1 according to the ranking selection. Then F3 is having the rank 2, this divided by the sum of the rank values. So, this is 0.2. Similarly, your F2. So, this is the rank 3 divided by 10, that is 0.3. Then comes your F1, that is 4 divided by 10, that is your 0.4. Now, you see the probability value for F1, previously it was 0.8, now it is 0.4. For F2, previously it was 0.1 and now it is 0.3. F3, previously it was 0.07 and now it is 0.2, and F4, previously it was 0.03 and now it is 0.1. Now, here if you concentrate and if you compare these two methods in terms of the probability values of only F1, here it was 80%, 0.8, and here it is 0.4. So, there is a chance that I am going to give chance to other solution to come forward towards the mating pole. So, here the diversification will be better compared to this, and if you follow and if you give more chance for diversification, there is a possibility there will be less chance for premature convergence. So, in ranking selection, the chance of premature convergence will be less, whereas in case of proportionate selection, that is the Rouleau-Wheel selection, the chance of premature convergence will be more. So, this is the advantage of this particular the ranking selection. Now, this ranking selection is once again one proportionate selection, but in terms of the ranks, but not in terms of only the fitness values. So, this is the difference between the ranking selection and the proportionate selection, and generally we prefer the ranking selection because it has got less chance of premature convergence. So, this is what I discussed. Now, here I put one note that the rank based proportionate selection scheme is expected to perform better than the fitness based proportionate selection. The reason I have already discussed. Now, I am just going to discuss another reproduction scheme, which is popularly known as the tournament selection, and it has become very popular. Nowadays, we generally use the tournament selections only. Now, what I do is we have got the population size denoted by capital N. We select the tournament size small n. Now, if capital N, that is the population size, if that is equal to 100, we take this tournament size small n might be equal to 3, 4, 5, something like this. Now, once you have taken this tournament size, so what we do is we take small number of solutions from the population at random using the random number generator and compare their fitness values. Now, supposing that I am solving one maximization problem. So, out of that small n of solutions, the solution which is having the highest fitness, that will be selected in the mating pool, and all the solutions will be returned to the population of solutions. Supposing that the tournament size is say 3, out of 3 I have selected say the second one as the best. So, that I will copy in the mating pool, but all 3 solutions should be returned to the initial population, and this particular tournament I will have to play how many times? Capital N times, and each time I am just going to select a particular the solution. So, this is what I discussed. Now, this particular tournament selection is computationally faster than the Rouleau-Wheel selection and the ranking selection. Now, another thing I just want to point out that GA on principle can solve the maximization problem. So, if we have the minimization problem as I discussed, we will have to convert it to the maximization problem. But if you use tournament selection, we need not convert the minimization problem to maximization problem, and directly we can tackle the minimization problem using the principle of tournament selection. Now, in tournament selection, if you want to solve the minimization problem, so out of small n number of solution, you select that one which is having the minimum fitness or the lowest fitness in the mating pool. So, directly I can solve the minimization problem without converting it into the maximization problem if I use the principle of this particular the tournament selection. So, this is one merit or advantage of tournament selection over the other selection schemes. Now, then comes the concept of the crossover, that is step 4. So, in crossover actually what we do is we exchange properties between two parents and consequently two children solutions will be created and some new properties will be coming due to this particular the crossover operator. Now, how to implement this particular crossover operator? To implement this particular operator, what we do is we first try to select the mating pairs, and each mating pair consists of two solutions. So, out of the population size of capital N, there will be n by 2 mating pairs, and this n by 2 mating pairs will be selected at random. Now, once you have selected this particular mating pair, now I can go for the crossover operator, and using this crossover operator I can find out the children solutions. Now, what we do is how to implement this particular the crossover probability, like how to decide whether a particular mating pair is going to participate in crossover or not. Now, supposing that the probability of crossover is a 0.8. Now, if it is 0.8, to implement what we do is we try to take the help of some sort of coin tossing. Now, how to implement the coin tossing in computer program? We implement with the help of one random number generator, which will generate a number lying between 0 and 1. Now, if the generated number is found to be less than equals to 0.8, so that is a success. That means the head has come for the coin tossing. So, what we do is we decide that that particular mating pair is going to participate in the crossover. Now, generally this crossover probability we take in the higher range, like starting from say 0.6 up to 1.0. Now, let us see actually how to implement so this particular the crossover operator. Now, here the number of individuals participating in crossover can be calculated. Now, supposing that the population size is capital N, so there will be n by 2 mating pairs. For each mating pair there will be 2 solutions. So, it is multiplied by 2 multiplied by P c. So, this is nothing but n P c. So, this n P c is nothing but the number of individuals participating in crossover. Now, let us see how to implement the various crossover operators. Let me start with the single point crossover. Now, here the principle is very simple. Supposing that this is the a particular mating pair and this is parent 1, this is your parent 2, and supposing that there are 20 bits. Now, if there are 20 bits, there are 19 places for the crossover site selection, and this particular crossover site is selected at random. Supposing that this is the site which has been selected for the crossover at random. Now, if that is the crossover site, according to this single point crossover, actually what we do is the bits which are lying on the left hand side of the crossover site are kept unaltered, and whatever is there on the right hand side. So, we do the swapping. Now, if I do the swapping, what will happen is so whatever is there at the bottom, that will go to the top, and whatever is there at the top, so that will come to the bottom. But the left hand side of this particular the crossover site, that will remain the same. So, there will be no change. Now, if you follow this particular principle, then from the two parents PR1 and PR2, I will be getting two children. So, this is your child 1, this is your child 1, and this will be your child 2. Now, here I just want to mention that if I just keep the right hand side of the crossover site intact, and if I do the swapping on the left hand side, I will be getting the same children solution. Only thing might be child 1 will be child 2 and so on, that type of thing, but I will be getting the same set of two children. But on principle, we do not disturb the left hand side of this particular crossover site. The reason is the place value for the leftmost bit is much higher compared to the place value of this particular right hand side, and on principle we follow in GA the gradual search, and that is why philosophically we do not consider the high change, but by following these two methods any one. So, I will be by following these two methods you will be getting the same solution, but traditionally what we follow is whatever bits are lying on the left hand side are kept constant, and whatever is lying on the right hand side we do the swapping. So, this is the principle which we follow for the single point crossover, just to get two children solutions from the two parents. So, this is actually the single point the crossover. Now, then comes the concept of the 2 point crossover. Now, here actually what we do is we select two crossover sites like the crossover site 1 and crossover site 2 once again at random, and the principle is very simple. So, whatever bits are lying on the left hand side of the first crossover site and the bits which are lying on the right hand side of the second crossover site, those are kept unaltered, and the bits which are lying in between the two crossover sites, so there will be swapping. And if I follow this particular principle, so I will be getting, if I follow this particular the principle, so I will be getting the children solutions like this. So, here these are kept constant and all such bits are kept constant, only thing whatever is lying in between the two crossover sites, so there will be swapping. So, starting from the two parents, I will be getting two children solutions using the principle of the 2 point crossover. Thank you.